You have fallen into Event Horizon with John Michael Gadier. In today's episode, John is joined by Jacob Hackmisra and Dr. George Pritilotus. Jacob Hackmisra is a senior research investigator at the Blue Marble Space Institute of Science, focusing on conditions that allow life to survive and detecting signatures of biology or technology on other planets. Dr. George Pritilotus is a research scientist and future studies expert, particularly interested in anticipatory governance and ethics of advanced technoscience. Today, we're rethinking the infamous Kardashev Scale. Kardashev formulated it based on energy usage, the famous Type 1, Type 2, Type 3 civilizations. We are not yet at Type 1, and this has been raised before. It's an imperfect scale. The way we started approaching the problem is thinking about how Kardashev's original paper assumes a civilization expanding its energy use, but he makes a comparison to spatial scale. A Type 2 civilization uses all energy output from its star. You build Dyson sphere elements. The spatial scale is the whole solar system. Type 3 is the energy output of a whole galaxy. We separate these two dimensions. One could increase energy use keeping spatial scale the same, or increase spatial scale without changing energy use much. The Kardashev scale tells you a maximum. That's the maximum energy you can get from starlight. We started figuring out that we could use multiple futures of Earth's technosphere as analogs for looking for other technology-capable intelligences. The future doesn't have to be a single trajectory. When we analyzed the scenarios, only one had that 1% growth rate where you hit Kardashev Type 1 by 2025. We had 3 other scenarios with slow growth, less than 1% per year. We get 3 scenarios where growth stabilizes, a net zero sustainable balance. 2 scenarios have growth and collapse, then a post-collapse stable state. One oscillates on a 200-year periodicity between growth and collapse. Some scenarios have the technosphere just on Earth. Some span the whole solar system. In some, the biosphere and technosphere aren't even overlapping. It's quite diverse. Looking for techno-signatures like stellivores, stars that appear to be being drained physically, not just energy-wise, actually being stellar-lifted. Our collaborator Clement Vidal developed these ideas. We asked, what else could you do if you wanted more energy than starlight? You could eat your star. Instead of consuming photons, you consume stellar mass. If you were able to harness stellar mass as a food source, that might look like these X-ray binaries. Very powerful mass flows because one star is a black hole, neutron star, or white dwarf. Clement had ideas about looking for goal-directedness, one star moving toward another as its future food source, or stars positioned for navigation like a galactic GPS system. We used morphological analysis, originally developed by astronomer Zwicky, to figure out what other astronomical phenomena might exist that haven't been discovered yet. This produced a multi-dimensional solution space, with thousands of potential scenarios, 5,576. We systematically narrowed these down to a manageable set of 10 scenarios. We used Max Neef's framework of basic human needs, following a paradigm that human needs and human technology co-evolve. They need a common underlying thread binding them. The only common language we'll have with any technological civilization is anything that's overlapping. If there's another technosphere out there, we need some overlap, like radio transmitters or understanding the hydrogen atom. There's only one way to build a radio transmitter. An alien civilization has the same physics we do and is constrained by it. The electromagnetic spectrum does not go obsolete. Antiquated technologies can still be around. We're still burning wood and coal more than ever, even though we have more sophisticated ways of using energy. Radio may never go away entirely. We had several scenarios where Earth would be indistinguishable from nature. If you were pointing James Webb at the planet, doing spectral analysis, Earth really is in the same condition as pre-agricultural Earth. You might say, that's a planet with biosignatures, it might have life, and miss that there's technology. Some scenarios have technology across the solar system, but Earth itself is pristine. New techno-signatures we identified include satellites burning up in planetary atmospheres. The metals become aerosols that eventually fall to the ground and can be analyzed.